Okay, so today let's go ahead and find domain algebraically. So some things that you're going to need to remember is how to find the domains of specific functions. So as a general rule of thumb, most of the functions that you'll see are going to have a domain of all real numbers, or negative infinity to positive infinity. There are a few that have certain exceptions, one of them being a rational function or a fraction, where the denominator cannot equal 0, and radical or even root functions, which the domain cannot be negative. So you set whatever is underneath your radical greater than or equal to 0. And one more thing you just want to remember is when you have a rational function and in the denominator you have a square root. So if you have something that looks like this, only going to be denominator greater than 0. So let's go ahead and determine some domains of each of the functions in interval notation. So the first function here we have is a radical function. So we're going to take whatever is underneath the radical, so 2x minus 7, and set it greater than or equal to 0. When you solve, you're going to add 7 to both sides and then divide by 2. And x is greater than or equal to 7 over 2. Now, imagine that you have a number line. Here is 7 halves. And because it is greater than or equal to, it is equal to, it is including the 7 halves. And when you look, everything has to be greater than 7 halves. So including 7 halves and greater than. So how we go ahead and write our domain is you're going to use a bracket, 7 over 2, going all the way towards positive infinity with a parenthesis. In number 2, you have a rational function, so that means the denominator cannot equal 0. So when I solve that, I see that x cannot equal negative 5. So x can be all the numbers. If I have my number line, here is 5. X could be everything. It just cannot be 5. So we're going in both directions. We have the negative infinity and positive infinity, and just not including 5. So when you write your interval notation, you're going to have negative 5. You're going to have to include that little union or the or symbol in your domain. Okay, in number 3, you're going to have two things to look at. The first being in the numerator, you have a radical. So that means whatever is underneath the radical or inside has to be set greater than or equal to 0. So that's one domain. The second is that you have a fraction. So we know that x cannot be equal to 0. So that means the denominator cannot equal 4. So again, we're going to draw a number line just to be able to show both of these, because what we need to do is we need to combine these two restrictions together. So here we go. We are told that x can be greater than or equal to 0. So here we go, greater than or equal to 0 towards infinity. All right, so in the denominator, we're told you can have everything, you just cannot have 4. All right, so go ahead and see where these overlap. So we're not overlapping on the left side, so we got to have 0 starting off, going all the way to 4, doesn't include, or our union, we have 4 going all the way towards positive infinity. Okay, last but not least, we have, again, a radical in the numerator. So the inside is greater than or equal to 0. And the next thing we see is we have another radical, but it's in the denominator. So we cannot have it equal to 0. We know that x minus 4 just has to be greater than. So x has to be greater than 4. So again, let's draw ourselves a number line so we can use this. We are told 0 greater than or equal to 0. And then you're told, well, 4's not included, but everything greater than 4. So again, where do we have an overlap? We do not have anything overlapping here, so we're going to have 4 with parentheses going all the way towards positive infinity as our domain. If you found this video helpful in finding domain algebraically, go ahead and click the like button and subscribe so you can get notifications on future videos. Thanks for watching and have a great day.